Hey kiddos, more organic chemistry. Today we're going to look at a whole new branch of organic molecules called aromatics. More specifically, we're going to look at the benzene ring. Causes people a lot of grief because it doesn't follow many rules. Benzene just does its thing. Definition: a special class of cyclic unsaturated hydrocarbons is known as aromatic hydrocarbons. The simplest of these is benzene. 6 carbons, 6 hydrogens, a benzene ring. Benzene and structures based on benzene are called aromatics because these molecules have characteristic aromas. Depending on what the benzene ring looks like, the branches, etc., it's going to have a different scent. Benzene is a unique structure in that it does not follow the normal rules of bonding. It is a hydrocarbon ring that seems to have 6 unbonded valence electrons shared equally by 6 carbon atoms. Each carbon bonds 3 times. What? That's because it has moving double bonds. I know, right? Chemistry. So just like atomic theory, the theory behind the structure of benzene was revised a number of times to better fit the phenomena observed. And today still we're like, okay, what's happening here? What is going on? Things like it's both saturated and unsaturated have been said. Like it's kind of fun. But this is what it looks like. It has double bonds every second carbon. So here's a double bond. Here's a double bond, here's a double bond, but they're not stationary. They actually jump around. Here's a way of just showing that it's a benzene ring. We just put a ring inside that structure of 6, right? Or this is a really simple way of drawing it. I know. I don't know what to tell you. It's really fun. Love it. Okay. So it's also looked at as the single double bond hybrid model. So single double bonds, but the double bonds aren't stationary. They're constantly jumping from carbon to carbon, and it's still a theory. So really what it means is we really have no idea because it's just a theory. So, but naming, we got this. We know how to name. So the benzene ring can sometimes act as a parent chain or as a branch for larger molecules. Use the following steps. A, name the alkyl group followed by the benzene. For example, here's a methyl group. It's a methylbenzene, or you could draw it this fun way. It's considered to be in the first carbon, so we don't need to say 1. So the numbering of the carbon starts at one of the branches and goes clockwise or counterclockwise to obtain the lowest possible numbers. This is muy importante. Please highlight or put it in the vault. That means in your brain. Okay, depending on where it is, you're going to use those locant numbers, right? 1, 2. And you want the lowest possible numbers. It means like when you add them up. Okay, so this is 1, 2 diethylbenzene. We don't really have a choice because it could be 1, 2, same thing. This is 1, 3 diethylbenzene. What we don't want, see how this is 1, 3. 1 plus 3 is equal to 4. So this would be wrong. Are you guys ready for this? Are you ready? You can't name it 1, 2, 3, 4, 5, 6. This is 1 and 5. 1 plus 5 equals 6. 4 is lower than 6, so this is the right way to name it. Okay, here's an example of 1, 4 diethylbenzene. It's C2. Be careful with how things are drawn. It wouldn't matter which way you name it in this case because it would be the same. So just make sure you know that when you're adding it all together, it has to be the lowest number. When the benzene ring is considered to be a branch, it is called a phenyl group. So here we have 1, 2, 3, 4, 5. There's our benzene ring on the second carbon. 2-phenyl pentane. It's an ane because there's no double bonds. There's none. Okay, or triple bonds for that matter. So if 3 hydrogens are replaced, number so that the lowest possible number combinations is achieved, then name alphabetically. So this is 1-ethyl 3-methyl 5-propylbenzene, not 3-ethyl 5-methyl 1-propylbenzene. If you add 1 plus 3 is 4 plus 5 is 9. 3, well, I guess 1, but then also this would be the same, but also you want to start with the lower number, which is the 1, not starting with the 3. Does that make sense alphabetically? So ethyl, you're better off starting with the 1 there rather than the 1 at the very end because of the propyl. So a couple of little rules. So here's an example. Take a look. 4-ethyl 1,2-dimethylbenzene. So 4, 5, 6, 7 total, and not 1-ethyl 3,4-dimethylbenzene. In this case here, 4 plus 3 is 7 plus 1 is 8. And we have 4 plus 1 is 5 plus 2 is 7. So this is right. This is no bueno. So you got to play around a little bit with the benzene, with naming of the benzenes. So here's some practice. You can pause the podcast, try to name these, and then play to check the answers. And the answers: 1-ethyl 2-methylbenzene, 1-ethyl 3-methylbenzene, and 1-ethyl 4-methylbenzene. No big deal. Here it's more like, listen, we're starting with ethyl because it's alphabetical. And yeah, so make sure the ethyl is 1. So let's take a look at some properties of benzene. It's liquid at room temperature and it boils at 80.1 degrees Celsius. So it boils a lot faster than water. It's nonpolar, so it's insoluble in water. Behaves like an alkane. Addition reactions do not occur, but you can have substitution reactions. You can substitute, like here I'd have a hydrogen. I can substitute and make that a chlorine. It substituted out the hydrogen and brought in the chlorine. But you can't add it because it's considered, behaves like an alkane. In 1825, Michael Faraday was the first to isolate and identify. In 1836, Auguste Laurent, French guy, named it fen. In 1855, August Wilhelm Hofmann used the word aromatic to describe the family. And in 1865, Heinrich August Kekulé, or German, he had a dream. He had a dream about benzene, go figure, and kind of obviously talked a little bit about the double bond, not double bond, saturated, not saturated, things of that benzene has, doesn't have, because there's still theories. You're not going to be tested on the dates. It's just a little bit of FYI. Write the IUPAC names for the following aromatic hydrocarbons for practice. One is the benzene is the chain, the parent chain, and for the other, the benzene ring is a branch. So pause, write it out. Answer: 1-ethyl 2,4-dimethylbenzene, and the other one is 3-phenyl 4-propyl-octane. So A, the benzene is the parent chain, and for B, benzene is a phenyl, which means a type of branch. Draw the line structural formula for 1-ethyl 3-methylbenzene. First, draw the benzene ring and then add an ethyl group to any carbon of the ring. This carbon automatically becomes your carbon number 1. Finally, add a methyl group to carbon C, or C3, which can be clockwise or counterclockwise from C1. Either way, if it's clockwise or counterclockwise, it's still going to count from number 1, and it's still going to go towards that branch. And that's it, kiddos. Aromatics. Fun, hey? Have a lovely day and do some practice because soon we're going to be done with the first part of organic chemistry.